Here we're going to look at deciphering whether we have a function given a word problem. So we have D, that is standing for ampicillin dosage. So this is kind of like penicillin. It's in that family. It can be used for a lot of different respiratory infections, UTIs, ear infections. A lot of things can be solved using this antibiotic, but we want to get the dosage correct. So that dosage that is given out is expressed in milligrams, and it depends upon the weight. So here we're giving it to a child, and it depends upon the child's weight in kilograms. So we have this equation where D, which is the output, equals 100 times the input, 100 times their weight. Given the rule for finding the same maximum daily drug dosage for the children who weigh less than 20 kilograms, it's about 40 pounds. So looking at this relationship, so D is the output and W is the input just based upon the way that the equation is written. So looking at this first part, what are logical choices for the independent and dependent variables? So independent, the independent variable is the same thing as asking for the input. What are you plugging into this function? You're plugging in W, which is the child's weight. In kilograms. And you're getting out the dependent variable. Your output is D, the dosage, in milligrams. And this makes sense. You tell me a child's weight, and I'll tell you how much the dosage should be. So it wouldn't work the other way. You wouldn't say, well, the dosage is 500 milligrams, so we're going to need to make this child gain 30 pounds so that we can give them that dosage. No. You are given the child's weight. That's independent. You don't get to control that. But once you have that information, you get out the dependent variable. You get out what depends upon how much that weight is. So you get out the dosage that is suggested. So instead, tell me how much the child weighs, and I'll give you the dosage. So does this equation represent a function? Explain. So looking at this function, D equals 100 W. Does it look like each input is going to have exactly one output? That's what this is asking. A function is where each input, W, has one output, D. Well, realistically, if we think about somebody's weight, are we going to say, well, either we should give them 10 milligrams or 500 milligrams? Who knows? No. Once you know their weight, you should know an exact dosage that they need. Just thinking about real life. But even thinking about plugging numbers in here, are we ever going to get two Y values for one X value? And in this case, two dosage values for one weight? Well, we could test a point to see. You can't use trying one number to explain all numbers, but we could at least try it just to see what we get. So let's say their weight is 18 kilograms, because we said this is for 20 kilograms, 40 pounds or less. So their dosage is going to be 100 times their weight. So their dosage is going to be 100 times 18, so we're going to get 1,800 kilograms for that daily maximum drug dosage. So we can see each weight is going to have one specific dosage. We could test. That's not our proof because we need to explain it overall, because 18 isn't the only number we're allowed to plug in here. But we're going to say for each child's weight in kilograms. So if that's for each input, the child's weight in kilograms, there will be exactly one suggested daily max dosage. in milligrams. So this is a function. A fancy way of saying each input has one output. That was our goal here. To call it a function, we would say each input has one output. So we just need to write this in terms of the function and see if it holds true. For each child's weight in kilogram, there will be exactly one suggested daily max dosage in milligrams. So this has to be a function.